Dear friends, in this video we are going to discuss about safety, responsibilities and rights of engineers, public, society and stakeholders. This is a very important topic as far as ethics is concerned, since here we are going to discuss about safety and risk, assessment of safety and risk. We are also going to discuss about risk and benefit analysis using different graphs with the different examples, how to reduce the risk, and case study on Chernobyl and Bhopal disasters, and finally respect for authority. So safety is defined as the risk that is known and judged as acceptable. Knowingly, the risk may occur if we commit the new task. At the same time, we have to take precautionary measurements. What may be the risk will prevail if we continue the project. That is called the safety. The probability of safety can be mathematically defined as 1 minus probability of risk. Risk in the sense probability of occurrence multiplied by consequence in magnitude. So if you are doing 10 projects, we can't expect that all the 10 projects may be involved risk or some other unwanted things. Maybe one or two. That is called probability. It may be 1 out of 10. It may be 2 out of 10. So we need not much concentrate on a risk. But at the same time, we have to take care of the risk involved, and we have to take care of the precautionary measures, how to overcome if any risk is going to happen. The destructive testing is another approach. That is, a testing is done till the components fail. It is too expensive but very realistic and useful. In automobile chassis and other important components, we will be doing the destructive testing. That is, we will load the chassis until it gets failed. If you are going to manufacture 1 lakh chassis, we have to ensure that the carrying capacity of the chassis should be more than enough. That is called a destructive testing. Till it gets failed, we have to load the machine or equipment or any component. Another approach is prototype approach. The testing is done on a proportional scale model, that is with all vital components fixed in the system. Dimension analysis could be used to project the results at the actual conditions. It is a prototype is a working miniature with all the components. It is very similar in working condition with the new or actual product. We can conduct various tests and we can project the results to the actual conditions. That is called prototype testing. Safety is the integral part of the engineering design. That is, in other words, according to William W. Lawrence, a thing is safe if its risks are justified to be acceptable. Risk is when a thing is or product is proved to be dangerous or hazardous, then it is unsafe. A risk is a potential that something unwanted and harmful may occur. A risk is the possibility of suffering, harm or loss. A risk may fall into one of the categories like low consequence, low probability. It can be ignored. High consequence, high probability, that has to be given importance. A disaster is a continued event, a state of unpreparedness. Risk analysis, we have to estimate the risk with the graph. The following graph will explain. See, if you look at the graph, cost of maintaining the safety. In the y-axis, we are looking at the cost or losses. In the x-axis, we are looking at the safety. The middle point shows the level of safety, that is optimal level of safety. Towards right, low safety, high risk. Towards left, high safety, low risk. That is vice versa. If the safety is high, the risk is low. If the risk is high, safety is low. But we have to compromise on both the things. That is why we have to find optimal level of safety as we are looking at the graph. At the same time, we should not spend more amount from the safety aspect point of view. The cost of the product will increase. If we give more importance for the cost alone, then we will not be able to produce correct product at the correct price. So all those things we have to consider safety as well as the cost of the product, or losses will incur in the product manufacturing. So if you look at the medical example, risk of illness is given along x-axis and the risk of therapy is mentioned along y-axis. See, if you look at the 4 quarters, high risk of therapy, low risk of illness. If the treatment is prepared well and proper treatment is going to give the low risk of illness. Illness will be very, very low. If you come to the right side, high risk of therapy and high risk of illness. Sometimes, if you are taking too much care, it may not result in good. That's called high risk of therapy and high risk of illness. Too much of risk we should not take. Risk we can take, but it should be within the limit. Low risk of therapy, low risk of illness. In some cases, it is applicable. Low risk of therapy and high risk of illness. Depending upon the nature of the disease, we have to decide about the risk of illness and the risk of therapy. In the Chernobyl case study, it is a nuclear accident. It happened because of lethargic attitude of engineers working on the site. They falsely assumed that by closing the valve, the coolant may not circulate. But the reverse thing has happened. The closure of valve caused a huge disaster and resulted in many lives. So each and every aspect in maintenance is very much essential. That is, safety is very much essential. So that is the essence of this case study. The respect for authority means without proper authority, the employees may not adhere to the rules and regulations of the situation. So we have to give respect for authority. At the same time, the authority who is getting the work done from the subordinates has to have more knowledge about the particular product, so that he can intervene and explain, and he can get the doubts the employees get the doubts clarified, and he should be competitive enough to get the work done from the employees. So these are the things we have to observe from this video. Thank you for watching this video. Thank you.